Okay, we've been working with expressions in x squared, and we're now going to look at the graphs linking y with x squared. We've already done graphs with y is equal to x. Now let's see what they look like when we have y equals x squared. So we're going to plot points just like we did with linear graphs and see and draw the picture. So first of all, let's fill out the table of values. When x is negative 3, what's y? So what's negative 3 squared is 9, because two negatives make a positive. Negative 2 squared is 4. Negative 1 squared is 1. 0. 1 times 1 is 1. 2 squared is 4. And 3 squared is 9. And notice the symmetry of the numbers. Okay, let's plot these points on the graph. Now we'll move it down so we can see the graph, and we can just fit it in. So let's start with these pairs make a coordinate pair. So when x is negative 3 down here and y is 9 here, we're going to put a cross. Negative 2, 4, when x is negative 2 and y is 4, put a cross. Negative 1, 1, put a cross. 0, 0, 1, 1, 2, 4, 3, 9, and it's about there. Okay, so we may or may not join them up, but if we join them up, make sure you join them in a nice smooth shape. It's not very good, but try not to wobble and try not to make the line too hairy. And that is our parabola y is equal to x squared. And there's quite a few shapes in nature that are parabolic. So not too pointy, just a nice smooth parabola. And your teacher will talk about other things that are parabolic shapes. Okay, let's now go to draw y equals x squared plus 2 on the same graph. So we'll do the table first and then we'll move it back up and plot it. Now, when x is negative 3, what is negative 3 squared plus 2? Negative 3 squared is 9 and plus 2 is 11. Now when x is negative 2, we get negative 2 squared is 4, plus 2 is 6. When x is negative 1, negative 1 squared is 1, plus 2 is 3. When x is 0, you just get 2. 2 is 2. When x is 1, 1 squared is 1, plus 2 is 3. Now you notice I should get those numbers going up there. 2 2s are 4, plus 2 is 6. Yes, and what should that one be? 11, hopefully. 3 3s are 9, plus 2 is 11. Now I'm going to plot them, and I'll change my colour here. So negative 3, 11. So I'll just move this up a wee bit, hopefully. Whoops. I'll move that up so I can see where 11 is. Negative 3, 11 is going to be up there. Negative 2, 6. Negative 1, 3. 0, 2. And the next one is 1, 3. 1, 3. Now notice I should match going along here. 2, 6, because it's symmetrical, and 3, 11. 3, 11. Now if I was to join that, it's a bit hard on this computer. If I was to join it up, oops, and that is a picture of y equals x squared plus 2. Now it's still the same shape as y is equal to x squared, but it has been lifted up. See how it's been lifted up 2 spots? So it's as though you've taken the x squared graph and lifted it up 2. And you can kind of give a clue what's going to happen by this here. Now, what do you think if I plot x squared, y is equal to x squared minus 2? Let's have a look. Let's plot it. Plot the numbers first. So when x is negative 3, go back to red, x is negative 3, I better bring the equation into the picture. There it is. When x is negative 3, what is negative 3 squared? That's 9. Take away 2 is 7. When x is negative 2, negative 2 squared is 4. Take away 2 is 2. Negative 1. Negative 1 squared is 1. Take away 2 is negative 1. When x is 0, we're just left with negative 2. When x is 1, 1 minus 2 is negative 1. When x is 2, 2 2's are 4, take away 2 is 2. Now I can see a pattern happening here. 3 squared is 9, take away 2 is 7. So it goes 7 2 negative 1, 7 2 negative 1, so it's symmetrical about that there. Now let's plot it. Alright, negative 3 7. When x is negative 3, y is 7. When x is negative 2, y is 2. When x is negative 1, y is negative 1. I'm going to move it down. What are we up to? Negative 1 is down there. 0 negative 2. 1 negative 1. 2 2. See, opposite that one. And 3 back up here. 3 7. And so we have our parabola. Whoops, going up. Sorry, it's a bit wobbly. And this is y equals x squared minus 2. Notice the same parabolic shape, but it's been dropped down 2 on the y-axis. And so moving up on the y-axis you add x squared plus 2, moving down on the y-axis is x squared minus 2. Right, let's see what this, and we're going to draw it on the same graph, but we'll do the table of values first. Y equals bracket x minus 2 all squared. Now this is going to move it somewhere else. Let's find out what happens. Right, when x is negative 1, y is, what's negative 1, negative 2 is negative 3. Square it, you get 9. When x is 0, negative 2 squared is 4. When x is 1, negative 1 squared is 1. When x is 2, 0 squared is 0. When x is 3, 1. When x is 4, 4. And when x is 5, back to 9. Okay, let's go back to our green and plot the graph. So hopefully you'll be able to see it. Let's start with negative. When x is negative 1, y is 9. And I'll just have to move them up here a bit. Negative 1, y is 9. There it is there. When x is 0, y is 4. Let's plot that. When x is 1, y is 1. When x is 2, y is 0. And you can see what's happening to it. When x is 3, y is 1. Now I'm just going to extend the axis along because I haven't got quite enough values in here. I'll go for 5. When x is 4, y is 4. And so we're coming up here. Oops. And when x is 5, y is 9. Oops, there's 4, 4, and 5, 9. It's a bit rough, but if we drew that in, it's coming down and then going up. Now notice what's happened to from y is equal to x squared, and I'll just, your basic shape of y is equal to x squared goes like that, and so you can see that this one that we've just done, where you've got y equals bracket x minus 2 bracket all squared, that moves it to the right. Moves to the right, moves the y equals x squared to the right. And it's moved it to the right 2 places. Now what we're forming here is a family of graphs. So what do you think? If you think x minus 2 all squared moves it to the right in brackets, and what do you think x plus 2 does to it? Just move that down. What do you think y equals x plus 2 all squared does to the graph? Okay, let's fill in the table of values. So when x is minus 5 plus 2 is minus 3. Minus 3 squared is positive 9. Minus 4 plus 2 is minus 2. Minus 2 squared is 4. Now if you do this on the calculator, if you can't do it in your head, when x is minus 3 plus 2 is minus 1. Minus 1 squared is 1. When x is minus 2 plus 2 is 0. So that will be 0. When x is minus 1 plus 2 is 1. 1 squared is 1. And we should get a repeat of the above numbers. When x is 0, 2 2's are 4. And when x is 1, 2 plus 1 is 3. 3 3's are 9. And if you've predicted correctly, this format, it should move it to the left. The basic x squared graph to the left. So we'll bring the graph up. Yeah, hopefully we can see it still. Okay, when x is, now this time I'm going to just add a few more here. Not quite long enough. Minus 4. It's a bit rough, but give you the idea. Right, when x is minus 5, y is 9. So there's 8, there's 10, so 9 in the middle. When x is minus 4, 4. When x is minus 3, y is 1. When x is minus 2, there it is 0. When x is minus 1, it starts coming up again. 0, 4, and 1, 9. And if I was to connect those up, whoops, really hard on this, and up we go. But basically, can you see that the vertex of the parabola has moved 2 to the left? And whenever you have a plus in the bracket, it moves the parabola to the left. So these are known as our family of graphs, and you have to note the patterns. So basically we have our y equals x squared, y equals x squared plus 2, y equals x squared minus 2, y equals bracket x minus 2 all squared, and y is equal to bracket x plus 2 all squared. And we can do the same with y equals negative x squared, and you can have the same patterns going. So it's really pretty.